Okay, so it's definitely theoretical. And these vocab ones, you can always look them up if you don't remember. Okay, which of the following could be used to determine if a coin is a fair coin? We would call that an event. Ooh, or empirical probability. I think this one's empirical probability. Yeah, so empirical probability is a way of determining if something is fair. Okay, so in this one, use the spinner shown is equally probable, blah, blah, blah. We want to find the probability that it will land on blue and then on gray. So what you do when you find probability of two events is you multiply them together. Okay, so the probability of landing on blue, there are 3 of them out of 6 possible spaces. So this is probability of blue. And if we want to find the probability to land on gray, there's 1 gray spot over 6 places. So all we have to do is multiply across. 3 times 1 is 3. And 6 times 6 is 36. And then we reduce. That would be 1/12. So you find the probability of blue, and then you find the probability of gray, and then you multiply. So excuse my coughing. Goodness. Okay. Single die. I'm thinking this is a standard die. Find the probability of rolling a 2 the first time and a 1 the second time. So this is just one dice. There's only one side that's a 2, so it's going to be 1 out of 6, and a 1 the second time. That's another 1 out of 6. So we'd say 1 out of 36. So there's a 1 out of 36 chance of that happening. Remember, to find the probability of those compound events, you just find the probability of each one separate and then multiply it together. Okay, a coin is tossed and a die is rolled. Find the probability of getting a tail and a number greater than 4. So again, we're going to find the probability of getting tails. So there's one side that's tails out of 2 possible sides. And number greater than 4, well, if you think of a standard die, there's a 5 and a 6. So there's 2 sides that are greater than 4 out of 6. So we multiply across, we get 2/12, which is the same as 1/6. 1/6. We're almost done. Okay, Elizabeth, that's my daughter's name, brought a box of donuts to share. There are 24 dozen donuts, or excuse me, 24 donuts, that would be a lot of donuts, in the box, all identical. 5 are jelly filled, 4 are lemon filled, and 15 are custard filled. You randomly select one donut, eat it, and then select another. Find the probability of selecting 2 lemon filled donuts in a row. So first time, there are 24 donuts. And then we're going to take how many are lemon filled, and there are 4. So that's the probability of selecting a lemon-filled donut the first time. Now we're going to multiply by the probability of selecting a lemon-filled donut again. But now you ate a donut, so there's only 23 left. And there are only 3 lemon left. So you'd be 7 out of 24 times 23, 552. I'm going to say that might reduce, so I'm just checking it on a calculator, and it doesn't. Of course it doesn't. 7 is prime. Duh, Jen. Okay. So we're going to type in 7 out of 552. Oops. That is incorrect. What did I do wrong? 5 are jelly-filled, 4 are lemon-filled. eat it, and then, oh my gosh, guys, excuse me, 4 times 3 is not 7. You're probably like, Jen, it's 12. 4 times 3 is 12. It's a little late. So 12 out of 552, 1 out of 46 that does reduce to. So you can see it's really easy to make a mistake like that on this stuff that seems like you're whipping through it. Just, double check your answers and use Desmos to help with reducing fractions. Okay. So we're choosing group members. Okay. So 4 Democrats, 9 Republicans, and 4 independents. So altogether, it looks like we're doing 17 people. 17 people. We want to find the probability of selecting 2 Democrats. So first time, there's going to be 4 Democrats out of 17 people. Now, there's only 3 Democrats left out of 16 people to choose another one. And I'm not going to make that mistake again. That is 12 out of 17 times 16 is 272. That definitely reduces. And remember, you can go to, I'll show you, you can go to desmos.com and you can type in 12, this little fraction bar, 272, and then hit this little circle thing. 3 out of 68. 3 out of 68. Yay! So that is it. That test is not bad at all. So if I were you, do this one and then chapter 3, and then you're golden. So have a good night. Thank you for listening.